Every single day, more than 800 million rolls of toilet paper are used around the world. It's one of the most indispensable items in our daily lives, so essential that we rarely stop to think about it until we run out. To meet that staggering demand, factories produce and recycle millions of tons of paper every year through sophisticated industrial processes. But have you ever wondered how those soft, absorbent rolls are actually made? Today, we're following the entire process from start to finish, from raw materials and cutting-edge technology all the way to rolling, perforating, and final packaging. Stay with me until the end, because what you're about to discover will change the way you look at one of the simplest yet most essential objects in your life, right here on Stories Behind Everything. Toilet paper was first developed in 1857 by American businessman Joseph Gayety, who created and marketed it as a medicinal paper for treating hemorrhoids. His product came in individual flat sheets, moistened with aloe vera, and was sold as a luxury personal hygiene item at 50 cents for 500 sheets, a significant sum in that era. The rolled version, closer to what we use today, was patented by Seth Wheeler in 1890 and began being mass-produced by the Albany Perforated Wrapping Paper Company. Wheeler's innovation of the perforated roll made the product far more practical and convenient, and large-scale production made it affordable for everyone, revolutionizing personal hygiene habits in homes around the world. It's estimated that the average person uses about 100 rolls per year, which adds up to roughly 320 billion rolls consumed annually across the globe, making toilet paper one of the most manufactured consumer products on Earth. Toilet paper can be made from virgin pulp, extracted from trees like pine, spruce, and eucalyptus, or from recycled paper, sourced from used paper and cardboard collected from schools, offices, and households. To reduce deforestation and environmental impact, modern manufacturers rely heavily on recycling, but turning stiff, rough sheets of used paper into something white, soft, and absorbent is a remarkably complex process that has been refined and perfected over the past 130 years through continuous innovation in chemistry, mechanical engineering, and materials science. In today's impressive modern paper mills, high-quality toilet paper production begins with an innovative recycling process that gives discarded paper a second life. The cycle starts when tons of paper arrive at the factory, typically sourced from recycling centers, schools, offices, and universities. Upon arrival, the paper goes through a rigorous sorting and screening stage. Machines separate and remove non-recyclable materials such as plastics, metals, staples, paper clips, and any other contaminants that could damage equipment or compromise product quality. Paper with the least amount of ink is the most prized for recycling, as it contains purer cellulose fibers, is easier to process, and requires fewer chemicals to transform into soft, smooth toilet paper. The selected paper then enters the pulping process, the first major transformation. It's mixed with large volumes of water in a massive tank called a hydropulper, essentially a giant industrial blender. Inside this machine, powerful rotating blades break the paper down into individual fibers, creating a uniform slurry with the consistency of oatmeal. The pulp continuously passes through screens and centrifuges to remove any remaining impurities that slipped through earlier stages, including small pieces of plastic, adhesives from tape and labels, and tiny metal fragments from staples. If the recycled paper contains significant amounts of printing ink, it undergoes a flotation or washing process. Special chemicals are added that cause ink particles to become hydrophobic and attach to air bubbles. As the bubbles rise to the surface, they carry the ink with them, forming a dark foam that gets skimmed off and filtered out. This de-inking process can be repeated multiple times to achieve the desired brightness and purity. When needed, the pulp also goes through refining and bleaching stages. Chemical agents, typically hydrogen peroxide or oxygen-based compounds, rather than chlorine in modern mills, improve brightness and fiber quality without creating harmful byproducts. Virgin cellulose fibers harvested from sustainably managed forests can be added at this stage to further boost the final product's strength, softness, and absorbency. At this point in the process, the mixture is approximately 95% water and just 5% cellulose fiber, a ratio that might seem wasteful, but is necessary for the fibers to flow smoothly through the manufacturing equipment. The diluted pulp is then sent to a refiner, a critical piece of equipment whose job is to increase the paper's strength and improve fiber bonding. Inside the machine, rotating disc rollers equipped with precisely engineered grooves press and work the cellulose fibers together, creating more bonding points between individual fibers and increasing the paper's overall tensile strength. The refined pulp then receives additional water, diluting it further to about 99% water, and just 1% fiber. This extremely dilute mixture is fed into the paper machine, the massive, complex heart of the entire operation, where the magical transformation from liquid slurry to solid paper sheet occurs. The paper machine is an engineering marvel that can stretch over 300 feet in length. The diluted pulp is spread evenly between a rapidly moving wire mesh conveyor belt and a felt layer, passing between two large cylinders whose pressure and flow rate are carefully controlled to ensure uniform thickness across the entire width of the sheet. As the pulp travels along the forming section, the wire mesh moves at high speed, sometimes exceeding 60 miles per hour, while gravity pulls the water downward through the mesh openings. Small mechanical vibrators and vacuum boxes positioned beneath the wire assist in draining the water and help align the cellulose fibers in the direction of travel, which affects the paper's strength and tear properties. At this early stage, the material still contains about 80% water and resembles a soggy, fragile sheet that would fall apart if handled. The wet sheet then passes through a series of press rollers that squeeze out significantly more water, while simultaneously increasing the sheet's compaction and strength. Multiple press stages, each with progressively higher pressure, remove water mechanically rather than through evaporation, which is far more energy efficient. Up to 90% of the water removed during the entire papermaking process is reclaimed and reused within the factory, dramatically reducing water consumption and waste. After pressing, the sheet still contains about 50% moisture, far too wet to be usable. To bring moisture levels down below 5%, the sheet passes over a series of steam-heated cylinders known as Yankee dryers, combined with powerful ventilation systems that blow hot air across the paper surface. These massive cylinders, some over 18 feet in diameter, are heated internally with high-pressure steam to temperatures ranging between 200 degrees Fahrenheit and 300 degrees Fahrenheit. As the paper wraps around the hot cylinder surface, the remaining moisture rapidly evaporates. The speed at which the paper travels over the dryer and the temperature of the cylinders are precisely controlled to prevent over-drying, which would make the paper brittle, or under-drying, which would leave it weak and prone to tearing. A special adhesive called a creping agent can be applied to the paper during this drying phase. This chemical creates controlled microfolds in the paper structure that enhance softness, bulk, and absorbency, giving toilet paper its characteristic texture. The paper then goes through calendaring, where it passes between a series of metal rollers that apply heat and pressure. These rollers compact the fibers slightly and deliver a smoother, more uniform finish. The degree of calendaring is carefully controlled because excessive pressure creates thin, dense paper, while lighter calendaring produces softer, bulkier paper. The finished paper is wound onto enormous master rolls called parent rolls that can reach up to 50 miles in length and weigh as much as 6,600 pounds each. These massive rolls represent the raw material that will be converted into the individual toilet paper rolls consumers purchase. Before being cut and packaged, these parent rolls go through a battery of quality tests conducted by specialized laboratory technicians. Samples are tested for tensile strength to ensure the paper won't tear too easily during use, softness through standardized touch tests and specialized instruments, absorbency by measuring how quickly the paper soaks up water and how much it can hold, thickness using precision micrometers, and brightness using spectrophotometers that measure light reflectance. The paper must also pass safety tests, ensuring it contains no harmful chemicals or contaminants. Only after passing all these rigorous quality control checks do the parent rolls move on to the converting process. The converting process transforms the massive parent rolls into the individual consumer-sized rolls we recognize. This is carried out by fully automated rewinding machines operating at impressive speeds. The parent roll is placed on a rotating cradle that allows continuous unwinding. Electronic sensors monitor paper tension constantly to ensure it's pulled evenly without tearing or stretching. The paper may pass through an embossing system that stamps a raised pattern into the surface using precisely engraved rollers. These embossed patterns create micro-adhesion points between layers in multi-ply toilet paper while also improving texture, softness, strength, and absorbency. For 2-ply or 3-ply toilet paper, separate paper webs are brought together and bonded using either a special adhesive or mechanical embossing that interlocks the layers. Simultaneously, in another part of the facility, the cardboard tubes that form the core of each roll are being manufactured from recycled cardboard. Long strips are wound and glued around a rotating metal mandrel, forming spiral tubes that are cut to the correct length, typically around 4 inches. These tubes are automatically fed to the rewinding machine where they serve as the core around which the toilet paper is wound. The rewinding machine precisely controls the winding tension to create firm but not overly tight rolls. The large rolls produced at this stage, called logs, measure over 6 feet in length and contain multiple individual toilet paper rolls wound side by side. The logs travel by conveyor to the cutting station, where high-speed circular saw blades slice them into individual rolls, approximately 4 inches wide. Modern cutting machines can process dozens of logs per minute with incredible precision, ensuring each roll is exactly the same width. The cut rolls are automatically directed to the packaging line via conveyor systems. Sophisticated sensors verify that each roll meets weight and diameter specifications, automatically rejecting any that fall outside tolerance. The packaging line groups the rolls into packs of 4, 8, 12, or more units depending on the product configuration. A continuous roll of plastic film wraps each pack, which is then heat-sealed or adhesive-sealed to create a secure package. Modern packaging systems can wrap and seal hundreds of packs per minute. The finished packages are stacked on pallets using robotic systems, with each pallet holding hundreds of individual packages. The pallets are then wrapped in protective plastic film and labeled for shipment to distribution centers and retail stores worldwide. And that's how hundreds of millions of rolls of toilet paper are produced every single day around the world, through an intricate dance of recycling, chemistry, mechanical engineering, and precision automation. From waste paper collected at schools and offices, through chemical pulping and de-inking, precise paper making on massive machines, careful drying and finishing, to high-speed converting and packaging, every step requires sophisticated technology and careful quality control to produce the soft, strong, absorbent paper we depend on every day. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you proper recognition for your contribution. Thank you for joining us on this exploration through stories behind everything. Don't forget to like, subscribe, and stay tuned for more stories discovered through the smallest details.